Thank you very much. How are you guys doing? How are you doing? Okay, so first, I think I'd like to say thank you for coming to my talk. Actually, my name is Megasley, as he said, and I like to think of myself as a developer. Although I have like senior people here that are doing the real work. Actually, my work mostly falls within, training developers. I don't really do the training myself, but I kind of like put together the instructors that trains them on building on the Lightning Network. I guess that is why I am here to talk to you guys about Lightning Network. Um, so this is going to be a workshop, not really a talk per se. It will be conversational, and please feel free to stop me at any point in time to ask questions. The goal here is for you to understand how Lightning works. Um, I believe you may have received Bitcoin payments before. And if you have been orange pilled or you've received any form of Bitcoin payment here in the conference, there's a very high chance that what you received was via the Lightning Network, right? Not really on chain. If you received it and then you created an invoice, it was paid, and you received it instantly, then it was Lightning. And the goal is actually to let you understand how this entire protocol work. We won't go deep into the technicals, just on the surface, for you to understand how payment is moved off chain and not on chain. Basically, I hope you have a good time. Please feel free to stop me at any point in time. If you need sats also, I have my boss over there. He's available to share sats to you. Okay, so I think I'll start by asking a question. Let me not go here first. So how many of us here have heard about Lightning Network before? You have. Okay, how many of us understands what Lightning Network is? Okay, awesome. So we have people that does. How many of us have received the Lightning payment before? Almost everybody in the room. You've not received the Lightning payments. That's my birthday. He'll show you. Okay, so when you think of Lightning, or when we talk about Bitcoin generally, we talk about Bitcoin payments. I think the major thing we are referring to is always the Lightning Network. Lightning is what makes Bitcoin payments fast and cheap, right? Now, as the definition you see here, it's basically just a second layer. Okay, let me not assume that we all know about Bitcoin, right? Do we all know about Bitcoin? Like Bitcoin, generally, Bitcoin on chain. Okay, so the assumption is you know about Bitcoin and you've probably performed a Bitcoin transaction before. Lightning was built to actually improve Bitcoin, to help scale the Bitcoin network, right? The original workings of Bitcoin network is that if you make a transaction, you have to wait approximately 10 minutes for each transaction to be confirmed. And imagine going to, let's say, a market. We're saying Bitcoin is money and you can use it to purchase anything. Now imagine going to a shop to buy something, and the person accepts Bitcoin payment and you have to pay in Bitcoin. Now imagine how long it would take for you to wait. I mean, having to wait 10 minutes for the person to confirm that this Bitcoin transaction has been verified before you getting your goods. That is just for first confirmation. And as far as Bitcoin is concerned, transactions are considered irreversible when it has gone up to like 3 blocks or 6 blocks deep, right? Which means for each blocks, it takes 10 minutes. So for you to be sure that your transaction cannot be reversed, you have to wait for 60 minutes. So imagine you wanted to pay for an Uber, for instance. Will you have to wait for 60 minutes for that transaction to happen? It doesn't make sense. That is why Lightning was built on top of Bitcoin to help facilitate these kind of transactions. Now, the work of Lightning is basically just to help scale. it does not use a different token. Most people assume that the Lightning Network uses a different token other than Bitcoin. But Lightning does not use a different token. It uses real Bitcoin, and you're going to understand how that actually works in practice. So it's a second layer that is built on top of the Bitcoin blockchain, and it enables instant payments with tiny fees. Now, the problem it solves first, I think I've already spoken about some of them. Now, Bitcoin is money. We are trying to get Bitcoin to compete with, the traditional financial system that we're already used to. You're used to paying with Visa, you're used to paying with, let's say, MasterCard, your card generally. Now, if you want people to adopt Bitcoin, to use Bitcoin for payment, MasterCard allows you to make up to, I could be wrong, 20 to 50,000 transactions per second. And you're bringing Bitcoin a new form of money, and the maximum amount of transaction based on the on-chain protocol or programming is just 7 transactions per second. Now imagine you're only able to make 7 transactions per second. That is limiting in a way. So Lightning was built to actually solve this, because with Lightning, transactions are happening off-chain. It doesn't have to be confirmed on-chain. And with that, you can have millions of transactions per second. And of course, I've already talked about the 10-minute confirmation per block, which was a problem with the original Bitcoin on-chain. And then high fees, especially during congestion period. If you've ever tried making a Bitcoin transaction when the mempool is very full, you discover that you tend to pay higher fees, especially if you want your transaction to be confirmed faster, or you don't really have the luxury of time to wait. And that is a problem. But with Lightning now, you can send transaction with near 0 fees. Sometimes you can actually send it with 0 fees, depending on your connection with the node you're sending it to. And of course, it's not ideal. Bitcoin payment is not ideal for micropayments. Imagine trying to pay 5 shillings, or let's say 10 shillings for something, and you want to use the Bitcoin on chain to pay. You pay fees. It's not really ideal for you to use that. But Lightning allows you to make payments for as low as 1 shilling, right? Even less than that, because it allows you to make micro payments. And of course, I mentioned you can't really buy a coffee on chain or anything that you need to pay instantly. And with Lightning, you can actually do that. So how does Lightning basically operate? First, it uses what they call payment channels. Now, the original building of Lightning is that I am supposed to run a node, and a node is basically just a software that runs the Lightning Network protocol. There are different implementations from different companies. You can just pick anyone as someone that's technical. You're running a node. Now, the programming is that I am running a Lightning node, and let's say someone else, like my boss here, is running a Lightning node. And we decide to transact. If we decide to be transacting with each other, we open what we call a payment channel. A payment channel is basically something like, I'm trying to think of a better analogy to use. Let's use that coffee shop, right? You go to you go to a coffee shop and you want to buy something. Let's assume on-chain is like the tank you have, and then payment channel is more like you opening a tap. I don't know if that makes sense. You have a tap that is opened already. Sorry? I can rope. Okay, yeah, basically. So you open a tap, put a certain amount of money there, and say, this is how much I want to spend, or everything I'll be spending should be taken from this tap, right? Then at the end of the day, once we are done with all the payments, all the things I'm supposed to purchase, then you now check how much I have spent, because it will be updated per time. I think I'll explain that more as we go. And then you can then close the channel at the end of the day, and the funds goes back on chain. So what the blockchain sees is basically the opening transaction, and also the closing transaction. It doesn't see everything that happens outside. And a payment channel basically is just people coming together to lock funds into a multi-sig wallet. How many of us knows what a multi-sig wallet is? Okay, cool. So a multi-sig wallet is basically another type of Bitcoin wallet that allows two or more people to be signatory to it. It's just like having a bank account that has multi-signatory, that you can't just use one signature to withdraw funds from that. For you to actually withdraw funds from it, you have to it has to be signed by more than one person. So we have different types. We have 2 of 2, we have 2 of 3. 2 of 3 is it requires 3 signatures. I mean, you have 3 signatures for the wallet, but if you have a minimum of 2 signatures signed, then funds can be withdrawn, right? Lightning uses a 2 of 2 multi-sig, which means I'm putting the funds inside that multi-sig. You have the key. If I'm opening a channel to you, you have the key to that funds. I also have the key. So for us to actually take the funds out of that wallet, it means you have to approve, I have to approve. So I myself cannot take the funds out of it, right? So that's what a Lightning channel basically is. 2 parties come together, they log the funds into a multi-sig wallet, and every transaction they do basically is updated off-chain, right? I think there's an analogy I used when we were in Kisumu. I said, let's say you have a box, for instance, and you and your friend, you have a certain number of balls. For instance, you have 100 balls, and then you have a certain box here. You decide to deposit that ball here. You bring 50 balls, I bring 50 balls. Let's assume those balls are things of value, right? And whatever we are doing, probably we are playing a game, and for each game, I'm offering value to you. For each value, you have to give me a ball. Or if I'm giving you value, you give me a ball, right? Now, the ball, we are not basically receiving physically. It's more like we know we have 100 balls inside here, and out of this 150 is yours, 50 is mine, right? So when we perform transactions, let's say the first instance, I gave you something of value that is worth 2 balls. Now you're going to deduct out of my 50 balls, right? Now I have 48. 2 balls goes to you, and then you have how many now? 52, right? Now, if you add the total amount of balls inside the box, it's still 100. It doesn't change. But what changes is the amount I own and the amount you own keep changing, right? And that is updated. You might probably have like a paper, you're updating that. So it's not like the balls are moving literally, but you just keep tab of how much funds or how much balls is left for me and how much balls is left for you. At the end of the day, when you're done with whatever you're doing, you can now settle the payment. You bring the book you have to say, oh, out of all the things you've done, at the end of the day, I have 10 balls left and you have 90 balls. Now, the total amount of balls you still have in the box is 100. It hasn't changed, right? But what has changed is I now own 10, the person owns 90. So when you close the channel, that's how it works with Bitcoin. They lock the funds, he brings 5 Bitcoin, I bring 5 Bitcoin, for instance, we have 10 Bitcoins inside. So after all the transaction is done off chain and we decide to close the channel, then it will check how much funds is left for me, how much funds is left for him. Now, what on-chain sees from the beginning is the funding transaction of that wallet, right? It sees that you have 10 Bitcoin in that wallet. So when you're also closing the channel, on-chain still sees 10 Bitcoin coming out of that wallet, but the splits will be different now. 9, let's say 1 goes to me and 9 goes to the other person. Does that make sense at all? Okay, cool. So that's what payment channels are. Transaction happens off-chain, and when a channel is closed, and like I said, the key insight here is only the open and closed transactions touch the blockchain. So you already know what the Bitcoin blockchain is. It's only when a channel is opened that the transaction will be recorded on the blockchain, and when it's closed, you also see it recorded on the blockchain. But everything that happens outside of that is off-chain. That's why it's called off-chain transactions, and it's not recorded. And Lightning actually manages that. So this is an illustration of how it works. You see two parties, A and B, they're running a node and they decide to lock funds. So the funds move from the downside is assumed to be the Bitcoin on chain. They move the funds to their Lightning channels, and they can transact with each other off chain, send funds back and forth. And at the end of the day, once they close the channel, the funds returns back on chain, right? That is what payment channels are. So far, does it make any sense? Does anybody have any question? Okay, cool. So, yeah. Now, like I said, from the illustration I just made, it might be assumed that you need a direct channel for you to actually be transacting with someone. But Lightning actually makes it very beautiful that I don't necessarily need to have a direct channel with him for me to transact. If I can have a channel with someone that has a channel with someone that has a channel with him, then I can send funds to him. Right? How do I do that? It uses a process called routing. I send funds to Nifty, for instance. Nifty now pushes the funds to another person, and the other person pushes the funds to him. Basically, that's how payment channels works. Actually, you can see you have Alice, you have Bob. Now the goal is actually for Alice to send funds to David. Now Alice doesn't have a direct channel with David, this tab that we've explained. And what Alice does, but she does have a channel with Bob, and Bob has a channel with Carol, and Carol has a channel with David. So what the Lightning Network does is it uses Bob as a messenger, sends the funds to Bob, tells Bob, hey, push this amount of SAT. I'm trying to send these funds to David, send these amounts to David, and Bob sends it to Carol. Carol sends it to David. Now, these nodes that are in between, they have a form of incentives in the form of fees. So for every payment that is going through the hub, the node actually charges a fee, which is called routing fee. And the node runner decides how much they want to charge for the fee, right? That is usually the fee you pay when you're sending a Lightning transaction. If I have a direct channel with David, if Alice has a direct channel with David and she's trying to send payment to David, she's not going to pay a fee. It's basically zero fee because they have a direct channel. They can communicate to each other direct. But where the fees actually come in is when there are hubs in between. Like you have Bob, you have Carol in between. Yeah, so we have this globally connected network of Lightning that kind of like helps move liquidity around. So far we have about 20,000 plus Lightning nodes in the world. Some nodes are well connected than the others. We have big nodes on the network. They have channels with almost everybody. Now, your node automatically on its own, when you're sending the payment, chooses the path it decides to go. And it uses two things to decide which path you're sending the payment to. So let's say like I said, the analogy I gave, I have a channel with Nifty. Nifty has a channel with someone else, and someone else has a channel with the person I'm sending it to. But I also have a channel with another person that also has a channel with another person that still connects back to the same person I'm sending to. You see, I have two paths for the payment to go through. Now, what the network does is it basically looks for the cheapest and the fastest route to go to. So let's say if it decides to go through Nifty's path, and Nifty is charging a higher fee, and the other person in between is also charging a higher fee, it calculates the total amount of fee or the cost it would take for that funds to reach the recipient, and also checks this other path as well too. How much will it take? How many hops are in between? Automatically, it picks the one that is the cheapest and also the fastest path to go. So your node actually does that for you automatically. And yeah, so the process is called source routing. Basically, your node first checks where you're sending the payment to and checks the different path that is available. So if I check the nodes, it calculates that automatically for you and then sends the payment. Does anybody have any question at this point? Okay, I think I've actually explained this, like I said. So how routing works. Routing in Lightning is basically that process where nodes in the middle helps you push the funds to the person you're sending to, right? That process where they are helping you move that funds from one hub to another is called routing. And there are nodes on the network that are basically just there for this purpose. They act as routing nodes. They charge fees. Some of them actually do it for free without charging any fee. You use them to send payment. So you can, if you're running a node, you're building a product, you have a merchant, or you just want to run your own node, you have your own wallet, you can pick one of those nodes and connect to, and they'll be helping you with the routing process. So first, your node looks for the source, which I've already explained, and then the payment travels through a process called travels through an onion encrypted layer. Now, the question you might want to ask is, if I am sending the funds to Nifty and Nifty is sending the funds to another person and the other person is now sending the funds to the recipient I'm sending to. Now, what stops that other person or the people in between from stealing the funds that I'm sending to? What is actually preventing this is this onion encrypted layers. It's basically just a what's the word to use now? So it's a technique that actually, the best way to explain it is, let's say I want to send a message to someone from Alice to David, as we saw, and then I put the message or whatever it is, a letter, I put it inside a box, then put the box inside another box, put that other box inside another box again, put the other box inside another box. So you have different layers on top, like an onion, literally. So what the other person sees is what you want them to see. So when you send the funds, they can't actually have access to the funds. What they see is, hey, this is the letter. They open the layer. Oh, you're supposed to move this to Carol. Let's say it's from Alice now to Carol. You're sending this to Carol. They can't actually go beyond that. And what they need to do is just move it to Carol. Carol opens their own and they see, oh, you're moving this to David, right? Now, they can't actually get access to the funds. They can't steal it, because for you to actually steal it, which we are going to come to, for you to actually claim the funds, you need to provide a certain secret. We're going to talk about that real quick. And then it travels through that encrypted layers, and each participant forwards an eligible routing fee, which I mentioned there. The routing fee, the node actually chooses how much they want to charge. There are people that actually does that for free without you paying anything. And the payment is settled when the recipient actually receive the funds and provides proof of payment, actually, which we're going to talk about real quick. So Lightning is similar to what you already have, like the data packet on the internet, how data routes through the internet. But in this case, Lightning still uses the internet, but then it routes a value through distributed nodes. The magic behind the routing is it is a thing called hash time lock contract. Now, in that process where you're forwarding the payment to the person, you might also ask, what if the payment is stuck somewhere, right? You've sent the funds or you're sending a letter. If it's like a literal letter, I send a letter to this person and this person sends it to this person, and person A sends to B, B sends to C, and C refused to send the letter to the person that is actually receiving it, then it means the payments would be stuck or the letter would be stuck somewhere, isn't it? Now, what Lightning uses is it has like a set time for this payment to actually be fulfilled. If it expires, if that time passes, which is around 144 blocks or approximately 24 hours, if the payment is not claimed by the recipient, then the funds, the whole entire transaction fails, and the funds is returned back to the original owner. So that way, you don't really have funds stocked forever somewhere, and nobody can actually steal that fund. So that's what actually helps manage this, the hash time lock contracts. And so what Lightning uses to make payments, which if you have actually received the Lightning payments before, you may have noticed, is Lightning invoice. You create an invoice, sends it to the person you want to pay, or you want to pay you. The person either scans or copy and paste the invoice, and you receive it. Now, when you create the invoice has some details in it. What you see is just a long string of text that doesn't make sense. But those texts has some data in it that the nodes actually interpret. It has one of the things it has is a payment secret. So that is what also prevents the hops in between from stealing the funds. So I send the payment, the people that are passing through it. So when I create the invoice, when the rest, whoever you're sending the payment to create the invoice, it comes with a payment secret. It comes with a secret that only the person that creates the invoice can show to receive the funds. So when it passes through Alice, Alice can't claim the funds because she doesn't have the secrets to prove. Bob cannot claim the funds. Carol cannot claim the funds until it gets to the actual person that created that invoice, right? That is when the payment can be claimed. So when it gets to the person, all they have to do is to show the secrets, right? That is associated with that payment, and then they can claim the funds, right? So this is how a Lightning invoice, more like an anatomy. I'm so sorry. My Nigerian tongue is trying to betray me. So anatomy of a Lightning invoice. You see, when you look at it, it looks like a string that doesn't make sense. But if you really look at it in between, you see, your Lightning invoice always starts with an LNBC. Have you noticed it? Then after that, you have like a number, which is basically, okay, so this is how it looks. You have LNBC, you have a number, which is basically the amount. Then you have like the timestamp that we talked about. And every single details your node needs to know which channel to send this, which node or whoever the person is to send the payment to. And it also uses this to calculate the path that the payment needs to go through. And yeah, so that's how it works. And Lightning uses what they call boats standard for this kind of payment request. So we have like different standards that actually allows making payments. Now we have ones that allows you to. How many of us have used the Lightning address before? You have a Lightning address. So you might ask, if I need to create the invoice, how does the Lightning address work? That I don't necessarily need to create the invoice, but the person can still use the address to pay me. What happens with Lightning invoices is, with Lightning addresses, when you provide the address, it is actually mapped to what they call LNURL, if I'm not mistaken. Then what happens is the node that is supposed to make the payment, instead of you creating the invoice, the node sends a request to this other node to create the invoice and retrieves the invoice based on the amounts it has put and pays that invoice. So the invoice still comes from the node, but now the node is not doing it themselves. It is the other person that is making the payment that does that, basically. And so there is another phenomenon that prevents stealing on the network, and that is channel state and commitment transactions. So you might say, what happens if, like I said, when we decide to close the channel, for instance, we've created a channel and then we are sending payments back and forth with each other. What happens if one person decides to be smart, to try to act malicious, to claim the entire funds to themselves, or try to update an old channel state? Oh, really? Oh, wow. So my time is almost up, but yeah, I'm surprised too. Yeah. So what happens if someone decides to be smart, to act smart? You brought 5 BTC, I brought 5 BTC, and then for every transaction, remember, for every transaction that happens, the channel state is updated and a new commitment transaction is created to show how much funds you own and how much funds I own. What if at the point of closing the channel, the person decides to broadcast an old channel state that actually allows him to have more funds than the other party? What happens at that point? Then this is what actually prevents. If somebody tries to do something like that in any way, the network punishes them by actually allowing the other person to take all the funds. So you brought 5 BTC, I brought 5 BTC, but then at the point where we decide to close the channel, you decide to act smart to say, oh, this is how much I own, whereas that's not what you own. What the network does is it punishes you, right? The other person takes all the funds that was in that channel and you go with nothing. So Lightning, this actually makes it trustless in a way. So you don't need to basically trust the person you're opening a channel to. I can find any node on the network and just open a channel with them without being scared or worried that my funds will be lost, because if they try to act smart, then it's for my own benefit. Basically, I'm gaining everything. Um, yeah, so how does Lightning scale Bitcoin? I think I've already spoken about this, talked about the numbers and the routing. And yeah, I think that's pretty much it. Let me be sure. Okay, cool. So yeah, so we have the Bitcoin network that allows you to settle payments, but Lightning actually allows you to scale Bitcoin beyond just on-chain. It allows you to send payments in a fast and cheap and a more private way. Also, I did not mention this. Lightning actually gives you way more privacy than the normal Bitcoin on-chain, because everything that happens off-chain is not on a public ledger that, like the blockchain, where everybody can see. It's only between you and the person you're actually connected to. Right. So even the person that forwards the payment in between, they don't usually have all the information. All they see is this payment is coming from this person and I'm supposed to push it to this other person. They don't know the original person that sends the payment or where it originated from. So yeah, and yeah, that's basically it. Does anybody have any question? Thank you.
After they have come from the main chain, sorry, from the Lightning Network onto the main chain. So after people have sent money to each other and used those sats of Bitcoin.
Yeah. So one thing about this is that the blockchain, what it sees is just a normal transaction, right? It's not like it's like a special transaction. I remember I said that Lightning channels are more like two people locking a funds into a multi-sig wallet. You can multi-sig wallets, people use multi-sig wallet and you can send funds to multi-sig wallets and also withdraw from them. So what the blockchain sees is just a normal Bitcoin transaction, right? Into that particular wallet, right? So at the end of all the transactions, you decide to close the channel. Each of them presents their their Bitcoin wallets. You understand? So the funds is now split into two parts, minus the fees, right? Part goes to the other person A, the other one goes to person B. Now, the network also sees that the funds that was sent into this multi-sig wallet has been sent out, but it's going into two separate wallets now. Do you understand? So it's not like it has like a very special way that it actually sees those transactions. Does that answer your question? Any other question? Okay. Thank you very much.
All right, ladies and gentlemen, a round of applause for Megasley.